Welcome back to another exciting day in mathematics. Whoop, whoop. Warm up number 21 is on the screen. Let's get started, please. Yeah, there's a pass right there. Hurry back, please. There's 4 problems on the screen. You should be able to do number 3. It's the inverse. Number 2, it's solve that system. I left you a video lesson on that, and let's see how much you remember of that. Numbers 1 and 4 should be something that you did in the past, and I'm going to try and retrieve that from your long-term memory. Let's see how that goes. Copy and go. All right. For the sake of time and just to get us going, today's Monday. I go over the warm-up, so here we go. I'm going to make some space here just because there's a couple of things that I want to make sure that your brain reproduces before we get to that session. I'm going to work on number 1. Y'all ready? Here we go. First things first, it says simplify. Number 1A, first we need to rewrite this. Let's see if you remember. How do we write this, Mr. Q? Well, we need an exponent where the numerator is only a 1. So that means I need to rewrite it to 16 1/2 exponent times 3. And if you notice, I moved the 3 from the numerator to the side. You guys see that? And I replaced that space with a 1. Why do we do that, Mr. Q? Because we know that 1/2 exponent is the same as square root. Is it coming back for some of you? Yes, Mr. Q. So I bring down the 16, put that in parentheses, and what exponent do I have left? Q. How are we doing? Next, what is square root of 16? 4. So that means we bring down the exponent of 3, and that becomes 4 times 4 times 4, which is 64. Once again, this is just a review. You guys should have seen this in the past. I'm just trying to retrieve it before we get to that session in a couple of weeks. Okay? Next, let's go to number 1B. For 1B, whenever you have a fraction and there's a square root on the denominator, you cannot have a square root on the denominator. You only can have an integer. So how do we get rid of this square root, Mr. Q? We'll multiply top and bottom times that square root. So, what do we have? Well, let's see. On the numerator, we have 3 square root of 2. On the denominator, what is 2 times 2? 4, so that's square root of 4. Are we there so far? Next, the numerator, we can't do anything else with it, so it stays 3 square root of 2. How about the denominator? What is square root of 4? 2. Did we get rid of the square root? Yes, we did, Mr. Q. All right, pretty good. Is it coming back for some of you? Yes? Very good. 1C, we need to rewrite this where one of the numbers is a perfect square. Now, some of you are like, what does that mean, Mr. Q? Look up. What is 1 times 1? 2 times 2? 3 times 3? 4 times 4? 5 times 5? All those are perfect square numbers. So, what 2 numbers multiply give me 20 where one of the numbers is a perfect square? Tell your neighbor, one of the numbers is a perfect square. Yeah, Sarah's got it. Very good, Sarah. I see you. Victoria's got it. Let's go with Carlos. What 2 numbers? No. 4 times 5. That is correct. 4 times 5. Now, if you notice, one of them is a perfect square. Do you guys see that? What is the perfect square? The 4. So what is square root of 4? 2. That goes outside. So we're done with the 4. What's left inside? The 5. So we're left with square root of 5. Pretty simple, yes? All right, we're going to be doing this all week. I just want to make sure that you guys are retrieving that from your long-term memory because we need that. Go to number 2. It says solve that system. Now, think it was about 2 weeks ago, I left you guys a video lesson on solving systems by graphing. Is that correct? All right, so let's do this. Here we go. Can I graph this top one? Yes, Mr. Q. Let's see, y equals mx plus b. Where do I start, people? At my y-intercept, what is my y-intercept? -3, so plot your point. And once again, I said that you needed graph paper, right? What is my slope? 2 or 2 over 1. That means 2 steps up, 1 to the right, plot your point. Do it again. 1, 2, 1 to the right, plot your point. Do it again. 1, 2, 1 to the right, plot your point, graph your line. Here it goes. Let's get your arrows. So we're done with that one. However, look at this one. What do you guys notice? Is the y by itself? No. So that means I need to get rid of the x. How do I get rid of a negative x? Well, I add x to each side. So I'm left with y equals, what's on the right side? X plus 3. Now can I graph this second one? Yes. Where do I start? +3. What is my slope? My slope is 1 or 1 over 1. So I go 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right. Now I ran out of room, but hopefully yours did not run out of room. Hold on. This one kept going, kept going, kept going. Show your neighbor where both intersect. Where do both intersect? Let's see if you see it. So if this one keeps going, it's going to intercept over here at the between 6 and 7 of x. Yeah? All right, check with your neighbor, see what value is that. What is the point where they both intersect? Let me graph this. It's off my page. Sorry. All right, so let me see. Y, X. All right, check on your graph. You should have seen both of them intersect at 6 of x and 9 of y. Is that correct? Check your graphs. Do they both intersect at 6 and 9? Yes, Mr. Q. All right, so that's how you solve these. That's the solution, right? Solution, and it's where both intersect. Let's go to number 3. Find the inverse. We're going to go pretty fast. By now, we should be experts at number 3. So what do? We change first to y form. So y equals -2x plus 12. Leave x by itself, so I subtract 12, subtract 12. We're left with y minus 12 equals -2x. And last but not least, divide by -2, divide by -2. So we have y minus 12 over -2 equals x. Is that the inverse? No. We need to swap the variables. So we end up with x minus 12 over -2 equals y. This is the inverse. However, we need it in function notation. X minus 12 over -2 equals f inverse of x. Yes. So good question from Carlos. Mr. Q, do you want us to simplify this like that? It's -1/2 x plus 6, or do I leave it like that? Leave it like that if there's no graphing involved, so you can save time. But if they ask you to graph, then that means you need to rewrite this with slope and the y-intercept. Okay? All right, and number 4. Here we go. Now, earlier I explained what 1/2 is. Is that correct? All right, tell your neighbor what 1/2 is. What is 1/2 exponent? 1/2 exponent. All right, looks like Julian's got it. But since it's Monday, I'm going to go and do this with myself. 1/2 exponent is what? Square roots. Is that correct? So we write x plus 3 inside equals to 4. Next, to solve for x, we need to leave x by itself. So what is the inverse of a square root? What cancels a square root? Very good, an exponent of 2. Exponent of 2. Do that to both sides. This cancels that. We're left with x plus 3 equals to 16. And last but not least, subtract 3, x equals 13. All right? Once again, I'm going to be doing these all week, so you guys get plenty of practice. We need all that, guys, because it's coming up. Okay? Here we go. Copy the agenda, please. Warm-up number 21 done. We're still in the middle of transforming functions. Tonight's home play is 2 problems only. However, I did leave you some home play on Friday. Is that correct? Turn to your neighbor, let them know how many transformations were there. How many transformations? There was only 2 problems, but each problem had how many transformations? 4, so it's a total of 8. Go to Canvas, turn that in. 8 transformations. All right. Go to Canvas, turn that in, please. It's only worth double the points. I made it 200 points. How about them apples? Yeah, that's fine. Also, for tonight's home play, copy this code, PJR26, PJR26, PJR26. Write that down, please. PJR26 to access tonight's home play. Yeah. PJR26 to access tonight's home play. There's the agenda again, warm-up number 21, transforming functions, 2 problems only. Oh, I still haven't given you a code for that yet. Last night's home play Friday's home play is that. Go to Canvas, turn it in. There's 1, 2, 3, 4, 5, 6, 7, 8 transformations. So it should say 8 transformations, cubic, quadratic. Cubic, quadratic. Tonight's home play looks like this. Woo-wee. Let's go. All right, so I'll give you guys some time to turn that in. Also get a Cornell note going. You don't need a Fourier model. Give it about a minute. All right, here we go. I can transform a function using different parameters. I can transform a function using different parameters. By now we know what functions are and what they look like. Is that correct? Yes, Mr. Q. So on your screen, well, before anything, tell your neighbor an example of a function. Tell your neighbor an example of a function. Tell your neighbor, please. Tell your neighbor an example of a function. Tell your neighbor. All right, good. All right, so type it in there, please, on the screen. Give me an example of a function. Example of a function. All right, so we have those notes. We good? So which brings us to here. Look up to the screen. Writing utensils down. So we've been talking about parameters, and we said that parameters are numbers that change one function to another function. Is that correct? So far we covered 2 of them. What are the 2? H and K. So remind your neighbor what K does and what H does. Tell your neighbor what K does to the function and what H does to the function. What does K do? What does H do? All right. So, looks like Jaime's got this. So K goes what? Up and down in H? Left or right? That is correct. So we got this, right? So on your paper, write this form again, please. This is our general rule for right now. We've been working with these two parameters, g of x equals f, parentheses, x minus h plus k. You're writing that down. And underneath, you don't need to write parameter and all the information. Just write the general rule, this one right here. Okay? Underneath that, I want you to write parent functions, because this is how it's going to get interesting today. All right? Here we go. So, our form, g of x equals f of x minus h plus k, and as Jaime said, k goes up or down, h side to side. All right, but we've been covering so far 3 parent functions. The first one, look up, f of x equals x, write that down. This is what we call a linear. Why linear? Because the graph becomes a what? A line. The second one we've been covering is f of x equals x squared. This is known as a quadratic function. No, on your notes. Quadratic, and the graph looks like this. The third one that I smoothly introduced that last week is known as f of x equals x cubed. And this is known as a cubic. And the graph looks like this. Now let me show you what all 3 of them have in common. All 3 of them have this point in common. Put a point there. That point is 0, 0. This one, that point is 0, 0. This one, that point is 0, 0. And from now on, whenever I say the word, look up, whenever I say the word vertex, I'm referring to which point of all 3 functions? 0, 0. From now on, whenever I say vertex, you're thinking 0, 0. Are we there so far? Okay? So now, how do we use this to transform these? Well, check this out. If I want to move this one, look up. If I want to move this one up 3 steps, so what would I do to this? Well, it no longer is going to be f of x. It's going to be what? G of x equals x. And what do we do to move it up 3 steps? Plus 3. Some of you are like, Mr. Q, do we put the x by itself in parentheses? If that helps you, that's fine. There it is. Look at the second one. Let's say I wanted to move this one, check this out, 2 steps to the right and 5 steps down. Think about it. 2 steps to the right, 5 steps down. 2 steps to the right, 5 steps down. I would begin with g of x equals, parentheses, x. What do I write for 2 steps to the right? Minus 2. Now check this out. Since this is a quadratic, don't forget the little squared there. And 5 steps down, we do what? Minus 5. How we doing? Good? And the last one, the cubic. Let's say I wanted to move this one. Pay attention to this part. 4 steps to the left, 3 steps up. 4 to the left, 3 steps up. Turn to your neighbor, let them know what would you write for this one. 4 to the left, 3 steps up. How would you write that? 4 to the left, 3 steps up. All right, let's see. G of x equals parentheses x plus 3 cubed. And what did we say? 4 steps up? What was it? 4 to the left? All right, so then, yeah, I did that to see if you guys were paying attention. X plus 4 and 3 steps up. There it is. 4 to the left, 3 steps up, and that's our new function. Once again, we're using which lens? This lens of this general rule. What functions are we using, parent functions? Linear, quadratic, and cubic. Are we there so far? All right. So by the end of this week, we should be experts at these because we're about to introduce some more functions, all right, and more parameters. So with that said, we covered this. We went to these. We covered this. We went to these. And then we ended up with some of these. So we know what to do with each of these. We look for the number to see if it's outside or inside of the parentheses to know where it's going to move. And then we end up with our general rule. So which brings us, once again, to here. And just as Jaime said, this goes up and down. Positive goes up, negative goes down. This one side to side. If we substitute a positive value, it goes to the right. If we substitute a negative value, it goes to the left. But here's the trick. If we substitute a negative value here, this becomes a positive inside. That's where some of you still need to get that clear in your noodle. Okay? Are we there so far? All right. So with that said, copy this one on your graph paper, please. Example 1, super cube. And it reads, graph the function f of x equals x squared. This time, we're going to graph it without a table. You need to get experts at these parent functions. And then we're going to transform it using this. Here we go. So f of x equals x squared. Think about it. How does that look? It looks like this. Is that correct? All right. Think about the 5 points that we used last week and the previous week for that one. And tell your neighbor, what 5 points are we going to use? What 5 points? Think about it. What 5 points do we use? All right, here it goes. In case you forgot, negative 2, 4. Plot it. Negative 1, 1, 0, 0, 1, 1, 2, 4. Oh, that's f of x, sorry. All right. Now, does everybody know where I got those points from? Yes? Negative 2 of x, what is negative 2 squared? 4. Negative 1 of x, what is negative 1 squared? 1. 0 squared, 1, 1, 2, 4. Next, you're going to write this one. Show g of x equals f of x minus 4. Put a little square there. Minus 7. So, before we do anything, look at it. And I want you first to start with the vertex. What's my vertex, everyone here? 0, 0. So, I want you to move the vertex according to this. Tell your neighbor, and then Soleil is going to enlighten us. Tell your neighbor where to move that vertex to. What coordinate do we move it to? Talk to your neighbor. What coordinate do we move that vertex to? All right. Soleil, where do we move it to? To the right and down. Or in other words, look up 4 and negative 7. Yes? Let's see. So I move this vertex to 4, negative 7. So this is my new vertex. New. My old one was what? 0, 0. So now that we have the vertex, is it easier to graph the other ones? Yeah. One on the left, one on the right. Another one on the left, another one on the right. And we label that G of X. From 1 to 5, how comfortable are you with this so far? 5 4s, 5 4s. Okay. Send me your notes. All right, thank you for sending that in. Go to a new coordinate plane. Copy this one on the right or the left. Example 2 super Q. And now it says, graph the function f of x equals x cubed. Graph the function equals f of x equals x cubed. And once again, we're going to graph it without a table. We're going to graph that without a table. All right. F of x equals x cubed. And then we're going to show g of x equals f of x plus 7 plus 2. So first copy it. We'll do it together. But let me trigger your noodle. Y'all ready? Here it goes. On the previous one, look up. We graphed this one without a table. And how do we do it? So, in case you don't see it, here it goes. I looked at negative 2 of x, and I squared that, and that gave me what? 4. So that's how I got that. Then I go to the next one. What is negative 1 of x? Well, negative 1 squared, that gives me 1. 0 squared, 0. 1 squared, 1. 2 squared, 4. Therefore, look at this one. Start with negative 2. This is cubed. Tell your neighbor where we're going to place our first point. Negative 2 what? Tell your neighbor. Negative 2 what? Negative 2 what? You got it? All right, let's go with Natalia Espino. Negative 2 what? Let's see. This one says cubed. That means negative 2 times negative 2 times negative 2, which is negative 8. That is correct. That's our first point. Once again, we need to get used to these without the tables. It can go a little bit faster. My next value is negative 1. Negative 1 cubed. Tell your neighbor where we place that point. Negative 1 cubed. Negative 1 cubed. Tell your neighbor what you got. Negative 1 is what? Miguel. Negative 1. Okay, so negative 2, we cubed it. Is that correct? So that's negative 2 times negative 2 times negative 2. Next x value is negative 1. What does that mean? Negative 1 times negative 1 times negative 1. What is negative 1 times negative 1? Positive 1 times negative 1 is negative 1. Next value, 0. Tell your neighbor where that goes. 0, yes, that is correct. 0, 0, that's our vertex. Next one, 1. Tell your neighbor where to place that point. All right, let's go with Julian, 1 what? 1 is correct. And the last one, 2 what? Pass him one. Autumn, 2, 8. That is correct. And then we graph our cubic. And we label that f of x. So now they want us to transform it using this. So now we put a little cubic here on the outside of the parentheses. So we start with the vertex. What was my vertex for this one? It was 0, 0. And now we're going to move it to what? Tell your neighbor what my new vertex would be according to that. What would be my new vertex? So your neighbor, the new vertex. And then we're going to have Aliyah enlighten us with a new vertex. New vertex. All right. So Aliyah, where are we moving it to? Up to left 7. So if we're up 2, that means it's positive 2 here. Is that correct? And if we're going left 7, what is that number, everyone? Negative 7. So my new vertex is at negative 7, 2. And then we can now graph the other ones. The other one goes here and here. And then this one, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2. 1, 2, 3, 4, 5, 6, 7, 1, 2. And we label that G of X. All right, let me send you the screen so you can send me your graph. All right, thank you for sending that in. So let's see how well we did. On these next ones, don't do it on paper. You're going to do it on the screen. Okay, here it goes. All right, here we go. Look at this one. So they want us to graph f of x equals x squared. Then I want you to do the green one, So, with that said, on your screen, not on paper, I want you to graph me f of x equals x squared, 5 points, and then move it with the green one. Copy and go. For the sake of time, as you're finishing up, here it goes. This is how fast it should be by now. Look up, please. My original f of x equals x squared is negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. That is f of x. And now I'm moving this vertex to my new one, which is here. Is that correct? So my new vertex is 10 down and 2 to the right. So it's 2, negative 10. 2, negative 10. Hands if you got that by yourself. Okay. All right. So let's move on. On your graph paper, copy this one. Example 4. Don't copy the words, copy the graphs. Now we're going to be writing our equation from the graph. So let me zoom in. You have it already on your screen, but let me zoom in here. So copy those graphs. So our original is this one. So what is our parent function? F of x equals what, everyone? X to the second power, okay. But now we need to write our equation for this one. Ooh, let's go. So here it goes. I'm going to get g of x, parentheses x, squared blank. So if you look at the vertex, look at the original vertex, where did we move that vertex to? How many to the right? 6. And how many down? 8. So outside we write what? -8. 6 to the right, that was 6 with a little negative there. And this is our new function. Are we doing from 1 to 5? Where are we at? Okay, 5 4 5 4s, okay. Do another one. Go to the new graph. Copy this one. Should be on your screen. Let me zoom in just for the points. So our original one is f of x equals x to the what? Third. Yeah, that's our parent function. That one is that. But now we need to write it for this one. So follow the vertex of the original to get to that. Tell your neighbor, what do we do to get to the new vertex? What do we do to get to the new vertex? All right, looks like Renzo's got it. Very good, Renzo. Gio's got it. Very good, Gio. Go with Jacob. What happens from this vertex to there? What do we do? X plus 8 plus 2. Hands if you got that. That is correct. We went left 8. That means this turned into a positive in here. And 2 up. There it is. All right. From 1 to 5. I'll come through you with that. Okay, we're getting there. All right. Send me your notes, please. I want to see what you did. All right. And last but not least, check this out. Look up to your screen. Look at this table. Don't copy it. We're going to do that on the screen. Here we go. Let's do the first one together. It says, write a new function after the translation. So here's our parent function. What's my parent function? F of x equals x. Yes? All right. But then it says, translate up 3 steps. Translate up 3 steps. So what would we write? G of x equals x plus 3. That is correct. Not bad, not bad. We still have time before we start backing up. Go with the second one, quadratic. This is our parent function, and it says translate 2 steps to the right, 4 steps down. 2 to the right, 4 steps down. Write that in there. All right, if we get this one correct, we're done. If not, we're going to do a couple more, even if the bell rings. Let's see, who went last? Was it Autumn? Jacob, pass them one. Carlos. Okay. translate 2 steps to the right, 4 steps down. What would I write for my new function? G of x what? X negative 2 with a square minus 4. Hands, if you got that? That is correct. We'll stop right there. That's going to be the home plate for tonight. You're going to be writing equations from graphs and from instructions. Those of you following on YouTube, make sure you put in some work. See you guys next time. Peace.